So again, my name is Benjamin Baaske. I'm a laser scanning research associate for NCPTT. I've been with the center for almost a year now, but I was at Texas A&M previously and doing a lot of laser scanning research as well as photogrammetry in the context of architecture as well as archaeology. So my background is in architecture, archaeology, and historic preservation. Today we're going to be looking at the Teague Research Center project. So we've been kind of looking at a broad swath of different sites and buildings today. And this is going to be a very pointed, specific case study where we're looking at one building and its historical background, and then the laser scanning documentation that goes into that building. So first I'll go through some of the history, where it gets its namesake, the construction process, how this building came to be, how it was going to become this central hub for the new emerging space research program at Texas A&M, how it functioned in terms of the programs that all of these facilities had embedded within them, and how it is significant architecturally from a kind of architectural design standpoint, and the documentation of the building itself. So it gets its namesake from Olin E. Tiger Teague, who is an Aggie, a former student, as well as a veteran in World War II. And he served in Congress for about 40 years. So at the time of this building construction, in the 60s, he had been in Congress for about 20 years. And he was a chair leader for Veterans Affairs, as well as the Manned Space Program, and leading majority member on the Committee on Science and Astronautics as well. So all of those kind of intersect here and make him a good candidate for the naming of a space research hub at Texas A&M. So the initial proposal, which we see on the top here, is what gets termed, and we'll look at the kind of breakout of the complex of the buildings, is the TRC, the Teague Research Center. This is the initial proposal, is covered by a $1 million grant from NASA. The second scheme on the bottom adds another whole wing to the building, and then an additional floor. So the additional cost of this $665,000 had to be put up front by the university. NASA was only going to cover $1 million. Once all that gets approved, this construction begins in the summer of '65, concludes in the fall of next year, and then the building is dedicated in '67, with the sculpture out front, the exploration in space sculpture, being dedicated the following year. So here we can see one of the historical photos. This is actually before the dedication of the sculpture. It's about an 8-foot tall sculpture. We can see Diane Bean, one of the administration staff for the building, here for scale. And it depicts a rocket trajectory for escape velocity entering low Earth orbit. The significance for this sculpture has become kind of amplified over the years as the trajectory of the program for the building has changed from space research to now house geography as well as computing services. So now, once this central hub for space research, that program, that kind of functionality is no longer within it to that same degree, but we still have these large-scale artifacts that are right in front of the main entry to the building, as well as a shrine, for lack of a better word, to Teague on the interior, with many of his military accolades and a painting to Teague as well. So it became the new addition to these three other facilities that were at Texas A&M, and kind of concentrated all of that research, so to be a hub, a connecting point for all of those buildings. So the TRC, which also had a Computing Services Annex, and we'll look at how those break out, was the hub for the program that included buildings like the Data Processing Center, which is now the Computing Services Center, that physically adjoins. We can see that Here actually in the foreground, this is the data processing center. And the Cyclotron Institute and the Nuclear Research Center. The Nuclear Research Center is very far away. It's actually close to the airport on the other side of the highway from the university. All of the research that was within all of these facilities, we can see here. So activation analysis, hypervelocity, acceleration, solid propellants, aerodynamics, propellers, oceanography, nuclear orientation, fuel cells, biomedical engineering, rheology, plasma research, cosmic rays, structural shells, spacecraft cost analysis, materials, and computerized data handling. I didn't include all the information, but there is a nice booklet from the dedication to this building that goes into more in depth as to the new space program and all of the different assets that it has. So these are a few of those buildings that comprise the Space Research Program. So this is the Nuclear Research Center, Cyclotron Institute, and then the Data Processing Center that physically adjoins to it. I actually did get to visit the Nuclear Research Center as part of an archaeological conservation course. And as someone that's interested in architecture and historic preservation, I made the mistake of asking them, so do you have any drawings or like cross sections of this thing? And they just kind of looked at me funny because we had to go through all this security clearance for a nuclear research center. But I couldn't help myself. So I decided to ask anyways, and they just kindly continued on with the tour. Architecturally, so it's a mid-century modern building. We have a lot of these around Texas A&M's campus. Most of them are a healthy shade of tan or beige. This one is fairly similar. It's got a little bit more of a yellow hue to it, so it does, relative to the rest of the campus architecture, stand out. It does make arguments for brutalist or international style, with the care to attention to the color of the brick and the way that they were laid. So this is all very doing the 60s, 50s, 70s machine aesthetic of architecture. So this is becoming a machine for space research in the way that the house was a machine for living. Using the actual exhaust systems here to create these vertical striations. So each of these smaller stacks here along the building actually house the exhaust system. So we're using those systems and then kind of shrink wrapping the building in a way that communicate the function of it. Also, my kind of formal reading of it when I first, noticed the building after biking past it every single day during my master's and then finally noticing it proper when I was doing my PhD, is that it almost extrudes out kind of like a block of cheese or like mashed potatoes that you carve into with a fork and say, this means something. This contrast with this kind of cheese is a heavily tinted glazing and black cladding. So these openings are then taken advantage of for daylighting into the building. There's no reason to necessarily make the cladding in between a different or the same color, but to keep this kind of cohesive aesthetic whole. Something that the architects and engineers were interested in. There is a building on campus that I did not get a chance to document fully that takes this yellow brick and kind of amplifies it up, the Biological Sciences building. If you get a chance to visit campus, I highly recommend checking both of them out. They're kind of oddities on the campus, which is hard to find because they try to be very cohesive with the architectural style that is on A&M's campus. So this is the CSA and the TRC are what we focused on, or what I focused on with the documentation project. This began as a historical review, condition assessment of the building. It, at the time, had just cleared 50 years, which for our campus and for other campuses around the states barely passes the threshold of historic. And this is where it can become a critical moment for a building to do renovation or to demo it. We actually had one across campus that unfortunately met more of the demolition fate. I will give away the ending and say this one is fine. They did do restoration on the TRC foundation, which was one of the major condition assessment takeaways, that was deteriorating at a fairly rapid rate. It extends out past the envelope of the building, so it doesn't drain quite so well. That initial historic review and condition assessment also included exterior ground-based laser scanning, and then when more funding came forward, I was able to go back and then cap it off with the exterior roof-based scans, as well as the interior circulation spaces, corridors, and stairwells. So largely, this is what was gathered in the first phase of the project. So that was another takeaway from this that was useful for us going forward as to how we might approach a documentation project for the entire university. All of these buildings are in function. We don't want to be invasive to the inhabitants, so we try to phase everything out in a way that streamlines the process. So initially capturing it from the ground. In the future, we would probably use something like UAV. I opted for keeping a consistent data style using terrestrial laser scanning, same instrument, same medium for the whole thing. Previous project where we had stitched UAV to laser scanning data together, where we did not have good control. And if you are going to use those, you need good control registration in order to do that. And since it was just me, I just opted to keep the same throughout. So, and always getting roof access to a building that not too many people have access to is often fun, and a good day in the field. Can be a little, this wasn't too high, so you have the oceanography building that kind of imposes over you. So this is the instrument used, the Focus 3D, that has been updated since 2017 and 2018. This was pushing a little bit of the boundaries of what I had learned so far with laser scanning. We had used a lot of registration targets, as well as total data station to piece laser scan projects together. This was an attempt in kind of experimenting with how quickly could we do a building, how far could we get these distances apart, and not have to do the full setup before, and what kind of outputs would those yield. So not doing in-field registration and no targets, so kind of doing everything by eye and then finding out later when we return what those outputs give us. And these are some of those outputs. So we're getting good coverage between the two. We can see some of the detailing here and also how far we're getting. So these laser scanners, Faro typically will name them by the farthest range that laser can reach to and give you an XYZ measure point with then a colorized point here that it takes from an onboard camera. And you can see me protecting the scanner kind of splattered on the pavement behind it here. So these were a little difficult to cap together, but we do have some overlap so if I'm standing over here, I am going to be able to see this facade, and vice versa over here, I'm going to be able to see that. We also have this huge building that I can use some of the context to either use cloud-to-cloud registration, or I can manually put in things like planes or points. So the planes work very well for this style of architecture, where it's a very precise, clean, orthogonal facade. Similar to the oceanography building, which is a later 70s construction. So we can use these context elements to then register all of these positions together. Moving to the interior, it becomes much more complicated very quickly. So same scanner, same methodology moving forward. Moving along the building from level to level and through the stairwells. In order to group these together manually, starting to cluster things by level and then by stairwell. So we can see that a little bit better here. So this is a registration view. This is the proverbial seeing how the sausage is made. This is actually going into visual registration and looking at this cluster here in red on level 1 and how that would tie to the level 2 in blue, that we're seeing some of that noise cast out here. And this can all be cleaned up in post. They're casting and reflecting in certain ways that we would not want in the final model because they're passing through. Some of it's passing through the glazing and some of it's reflecting off of the glazing. And how we might put together, or how I put together some of these clusters. So this was also a large learning experience for me, and that this data can be revisited. So potentially, doing what I did here and using this minimal overlap between this position where the stairwell is embedded in level 1 to the corridor at level 2 made sense at the time to someone in his 20s. After about 5 more years of doing this similar work, I think attaching the stairwells, the middle 2 here, to one of these corridors, and then starting to lock in each of those levels. And we can also see a little bit of what happens when we push the limits of the distance between our positions. We start to get we're still getting data coverage, but it's sparse. So we're seeing actual, real examples of, not just following the best practices or guidelines of the rule book for a laser scanner, but actually testing it and being like, okay, it is behaving in the way that one would expect. But we can still get decent data out of that here. Here we're just looking at the interior. We're looking at a kind of exterior elevation that renders like a cross section of the scanned point cloud. And some of these, this final image that we'll look at, this starts to allude to what became my dissertation research, was to look pointedly at the aesthetics of the point cloud. What are some of the qualities in that medium that are specific to the point cloud, is to say just taking a photograph or doing a drawing, doing field measures, using a tape and pencil. Something that we can do with this is what Andrew Saunders, he did with a lot of interiors of Baroque churches. He laid out some terminology that he claimed were specific to the point cloud medium, and this would be an example of a diaphanous body where we're getting that semi-transparent aesthetic of the point cloud and seeing not only what's on the exterior of that interior point cloud, but also passing through and actually seeing the interior. While this shows us an orthographic projection, how the stairwells kind of align and everything like that, this particular type of quality of the point cloud is better rendered in a 3D view, particularly with a perspective projection, because we get kind of distortions that indicate to us intuitively what's behind and what's in the forefront to us. So this research was funded by the Texas Old Missions Restoration, or Old Missions and Forts Restoration Association, as well as the San Antonio Conservation Society. And the instruments and a lot of the funding also came from the Center for Heritage Conservation at Texas A&M. So I just want to shout those out and thank them. There's much more depth to this. So if there's any questions on the historical background or some of the methodologies and outputs from this, I'm happy to field any questions. Thank you.